Hello everybody. So in the previous videos, we went through the different types of loads, the different types of supports. So you have four different types of supports, and different types of supports offer different types of support reactions, and we went through all the types of loading systems in the previous video. So by applying all the concepts which you went through in the previous video, we can solve the numerical. So we'll be starting the problems here. We'll be starting the problems in this particular video. So before we start actually solving the problems, we'll go through the steps to solve. So here in support reactions, all the problems are related to finding the support reactions. You'll be finding the reaction offered by the supports. Reaction offered by the supports. So what you'll be finding the reaction offered by the supports. You'll be finding this in all the problems. In all the problems, you'll be going through the reaction. Reaction will be unknown. Support reaction will be unknown. You'll be finding the support reaction. As simple as that. You have several steps to do that. You have several steps to find the support reactions, and we'll be going through all the steps in detail. So in order to understand the steps, let me consider an example. Let me consider a beam AB. So let this end be supported by hinged support, and let the other end be supported by roller support. This is just an example in order to understand the steps. So in the question, you'll be given with a drawing. That's it. They'll not mention the type of support, or nothing will be mentioned in the problem. You'll be just asked to find the support reaction by giving a drawing. In this way. So it will have all the types. For example, till here you have UDL, you have another point load, and from this particular point to B you have UVL. Let me consider the distances just for the example. 2 meters, 1 meter, 1 meter. Let this be 2 meters. Let the rate of load distribution be 2 Newton per meter. Let this be 3 Newton, and let this be 4 Newton per meter rate of load distribution. This is just an example to understand. So let us assume that this is the given problem. So you have to find the support reactions for this particular problem. This is an example problem. You have to find the support reactions. Let us go through all the steps one by one. Step number one is to identify the type of support and mark the support reactions. Step number one is to identify the type of support, and mark the support reactions. So this is step number one. So you have to identify the type of support. You have two supports here. So which type of support is this? This is a hinged support. So once you identify the type of support, you have to mark the support reactions. Hinged support will offer how many reactions? It will offer 2 reactions. One in Y direction and the other one in X direction. So this will be RAY and this will be RAX. 2 reactions. Which type of support is this? This is a roller support. Mark this reaction. Roller support will offer only 1 reaction. In Y direction, it will be RBY. I hope you know this. We went through this in the previous video. Simple support will offer only 1 reaction in Y direction. Roller support will offer only 1 reaction in Y direction. Hinge support will offer 2 reactions in X and Y directions. And fixed support will offer 3 reactions in X, Y, and MOX. So step number 1 is to identify and mark. Identify the support, type of support, and mark the support, the reaction. So this is step number 1. So So in step number two, you have to draw a drawing which is called as a point load drawing, or we call it as point load drawing. You have to draw point load drawing. Point load drawing. This is a type of free body diagram where all the loads are in the form of point load. We don't call this as free body diagram because forces are non-concurrent here. In a free body diagram, let us differentiate. Forces are non-concurrent. In a free body diagram, forces will always be concurrent. Here the forces are non-concurrent. So let me call it as a point load drawing or point load diagram. How to do this is the question now. See, in step number two, you'll be drawing a drawing which is called as point load drawing. So extend all of these lines. Extend A, extend this particular line, extend this line, and this line. Reproduce the beam again. Reproduce the beam. So this will be A, and this will be B. And these are the intermediate points. 1, 2. That you have extended the same. Now, in this particular drawing, what you draw in step number 2, in this point load drawing, all the loads should be in the form of a point load. All the loads should be point load. So in the question you have UDL and UVL, is it not? In the question you have UDL and UVL, so you have to convert it back to point load when you draw this particular one. This drawing is very, very important. This is the most important step here. So this drawing is very important. In this particular drawing, all the loads should be in the form of point loads. All the loads should be in the form of point load. So convert everything into point load and draw this. Let us start from this end A. Mark all the forces. RAY. This is point load. RAX. Point load. From this point to this point, you have a UDL, uniformly distributed load. We don't want any other forms other than point load. So convert UDL into a point load. How to convert UDL into a point load? The point load converted from UDL will act exactly at the center of the span. This is the span. Span is 2 meters, so this should act exactly at the center. This will be 1 meter, and this will be 1 meter. What will be the magnitude of load? Magnitude of load will be W, which is rate of load distribution into the span. 2 into 2. 2 into 2. So we have converted this UDL into a point load. Now you have another point load here, which is already given as 3 meters. As 3 meters. This is 2 into 2 meters. Now from this particular point to this point, you have UVL, uniformly varying load. You have UVL. Again, you have to convert UVL into a point load. So UVL will always be in the form of a triangle which has base. This will be the base and this will be the apex. This will be the base and this will be the apex. Apex it is, and this is the base. Now for point load, what you convert from UVL will be acting at a distance of 1/3 from the base. 1/3 into 2 and 2/3 into 2. 2 is the span. 1/3 from the base and 2/3 from the apex. 1/3 of this span. 1/3 from the base and 2/3 from the apex. You have to consider this span itself and convert this UVL into a point load. Here UDL acts exactly at the center. Here UVL acts at a distance of 1/3 from the base. This is the base, and 2/3 from the apex. 1/3 of 2. 2 is the span. 2/3 of 2. This is the span of UVL. Got it. Now its magnitude will be half into W is 4 into 2. Half into 4 into 2. 2 and 2 gets cancelled. It will be 4 newtons. Done. Now coming to B, you have RBY. You have RBY. You have RBY. So this is the drawing. This is the point load drawing. This is 2 meters, 1 meter, 1 meter, and this drawing is very, very important. This drawing is very, very important. The entire problem depends on this particular drawing what you draw. The entire problem depends on this particular drawing what you draw. So in a point load drawing, you have to make sure that all the loads are, all the types are converted back to point loads, convert it back to point loads. This is very, very important. If you have UDL in the question, convert it back to point loads, and if you have UVL in the question, convert it back to point loads. That's why you draw it exactly under the question. You draw it exactly under the question so that it becomes easy for you to draw the point load. And if you have any inclined forces in the question, inclined forces should be resolved. Should be resolved. These are the points you have to remember in order to draw the point load drawing. Point load drawing. All the types of loads or forces should be converted back to point loads. And if you have any inclined force in the given question, you have to resolve. So step number 2 is to draw the point load drawing. Then step number 2 is to draw the point load drawing. Now step number 3, the last step. Just have 3 steps here. Step number 3, this step is very, very important. Step number 3 is to apply the conditions of equilibrium. How many conditions are we supposed to apply? 3 conditions. Why? Because it is non-concurrent. Because it is non-concurrent. If you have a concurrent force, if you have a free body diagram, you should have applied only 2 conditions. Summation of fx equal to 0 and summation of fy equal to 0 would have been sufficient. But here, it is a non-concurrent force system. So 2 conditions will not be sufficient. You have to apply the three conditions as well. Which are the 3 conditions? Summation of fx equal to 0, summation of fy equal to 0, and the moment either about A or B should be equal to 0. Moment about A or B should be equal to 0. Moment about A or B. Either A or B should be equal to 0. This is how it goes. Got it? Summation of fx equal to 0, summation of fy equal to 0. Moment either about A or B should be equal to 0. 0. So by applying these 3 conditions, you can find RAY, RAX, and RBY. Our ultimate aim is to find these 3 support reactions: RAX, RAY, and RBY. These are the support reactions which we are supposed to find using these 3 steps. Step number 1 is to identify the type of support, mark the support reaction. Step number 2 is to draw the point load drawing right below the question in this way. And in step number 3, we'll be applying conditions of equilibrium. Summation of fx equal to 0, fy equal to 0, and moment either about A or B should be equal to 0. And finally, you'll be finding RX, RAY, and the other support reaction. This is how it goes. So these are the steps. So let me solve a problem as well in this particular video, and let me continue with the other problems in the upcoming videos. Let me solve a problem in the video. I'll just show the problem. So in the problem, the support reactions are already marked, because I insist you to mark the support reactions in the question itself, so that it becomes easy for you to draw the point load drawing later. So this is the first question in your notes. This is the first question. Let me draw the question and let me explain the problem. A very simple question this is. You don't have any complicated steps. So A, B, you have 2 points. At A, you have a hinged support. At B, you have a roller support. And intermediate, you have 2 point loads of 40 kilonewton and 20 kilonewton. 40 kilonewton, 20 kilonewton. And UDL is spread for a span of 3 meters. Of rate of load distribution 30 Newton per meter. This distance, let us mark distance. This is 3 meters. The first distance is 3 meters. 1 meter. 1 meter. So this is the given question. This is the question. Now again, what are we supposed to find here? Just read the question once. You are supposed to find the support reaction for a beam shown in the figure. Support reactions are to be found. So You have to follow the 3 steps. What is step number 1? Step number 1 is to identify the type of support and mark the support reaction. So which type of support is this? This is a hinged support. So hinge support will always offer 2 reactions, one in y direction. So this is R, A, Y, and this is R, A, X. 2 reactions. And roller support will always offer reaction only in one direction. This will be R, B, Y, R, B. So you're done with step number 1. In step number 2, what you're supposed to do, you have to draw the point load drawing. Point load drawing right below the question. Extend all of these lines. Extend all of these lines to draw the point load drawing. Right below the question. So this will be A and this will be B. This will be B. So let us start marking all the forces, and all the forces should be in the form of point loads. So at A you have R, A, Y and R, A, X. From A to this particular point you have uniformly distributed load. Uniformly distributed load. You have to convert uniformly distributed load into a point load, because in this particular drawing everything should be in the form of point load. So convert UDL into a point load. Point load converted from uniformly distributed load will act exactly at the center of the span. So this will be 1.5 meters and this will be 1.5. And the magnitude will be 30 into 3. 30 is the rate of load distribution, 3 is the span, W into L. And here we already have a point load of magnitude 40 kilonewton. This distance will be 3 meters. This will be 1 meter, 1 and 1. You have 40 and you have another load of 20 kilonewton already given here. And when we come to this particular point B, RBY will be support reaction. So this is the point load drawing, what we draw in step number 2. This drawing is very, very important. Just observe the drawing. You have all the loads in the form of point loads, and none of the forces are inclined here. All the forces are either horizontal or vertical. So if you draw this particular drawing properly, then you're almost done with the problem. Problem will be very easy. Now you'll be applying the conditions. Step number 3 is to apply the conditions of equilibrium. So first condition is summation of Fx equal to 0. Summation of Fx equal to 0. How many forces we have which moves in x direction? We just have one force, which is Rax. It is straight away equal to 0. It is straight away equal to 0. So the value of Rax is 0. Apply the second condition, summation of Fy equal to 0. Apply the second condition, which is summation of Fy equal to 0. Let us mark all the forces which moves in y direction. Ray minus 90 kilonewton minus 40 minus 20 plus Rby is equal to 0. Let me consider this as equation number 1 because you cannot solve this. So you have applied the second condition of equilibrium as well. Let us apply the third condition of equilibrium. Let me rub the question. Let us apply the third condition of equilibrium. Which is moment either about A or B should be equal to 0. Let me consider the A here. Moment about A should be equal to 0. Let this be the third condition. Moment about A in the sense Ray and Rax acts exactly at A. So these two forces will not produce any moment about A. Check whether this force of 90 kilonewton magnitude produces clockwise or anti-clockwise moment. Clockwise or anti-clockwise moment. It produces clockwise moment, is it not? It produces a clockwise moment. A clockwise moment. So it is plus 90 into perpendicular distance is 1.5. Please check it. Even this produces clockwise moment and even this produces clockwise moment. So plus 40 into 1 plus 2, which will be 4. 3 plus 1, 4. Or plus 20 into 3, 4, 5. And this will produce anti-clockwise moment. This will produce anti-clockwise moment. So minus R dy into 3, 4, 5, 6 is equal to 0. So Rby will be the only unknown available here. So you get the reaction about B, Rby. Rby will be the only unknown. Once you simplify this, you'll get the value of Rby as 65.83 kilometers. Please check this. I'm just referring the notes straight away to give you the values. I'm not calculating. So once you get the value of Rby, Substitute the value of RB by in equation 1 to get the value of RA, right? As simple as that. Get the value of RAY, and you'll get the value of RAY as 84.17 kilometers. So hope this particular problem is clear. The problem is very simple. When you compare it with the previous set of problems, these problems are very, very simple. Very simple. Steps are very easy. So you just have 3 steps here. First step is to first step is to identify and mark the support reactions, and in the second step, you'll be drawing the point load, and in the third step, you'll be applying the 3 conditions of equilibrium. Finally, to find RAX, RAY, and RBY. We got all the support reactions, as simple as that. So in the next video, I'll be solving a couple of other problems from your notes. This is the first problem number 1 from your notes. I'll be solving a couple of other problems as well in the next video. Thank you.